Hi, everyone. I'm Hunter Hawke, Security Solutions Architect at Smallstep. I'm joined today by Andrew Reed, software engineer at Smallstep as well, and
Hello.
our expert. Thanks for joining us today, Andrew. We asked our users, what do you hope to achieve with Smallstep? And often, the answer is securing Kubernetes ingresses, or Kubernetes ingresses. The Kubernetes documentation defines ingresses as an API object that manages external access to the services in a cluster, typically HTTP. Ingress may provide load balancing, SSL termination, and name-based virtual hosting. This is essentially any API that your cluster is exposed to. They are not encrypted by default, and exposing your Kubernetes cluster to an unencrypted service comes with huge security risks. We're going to mitigate that security risk for you today and get you up and running fast with securing your Kubernetes ingresses. In today's demo, you're using GKE to run the Kubernetes cluster and Cert Manager to manage certificates to an ingress controller. The authentication piece will be managed by Smallstep's open source project, Step Issuer. Step Issuer uses a password that is stored as a Kubernetes secret to authenticate to a JWK provisioner before the certificate request may succeed. Before I start, I want to populate the idea of a provisioner. As I mentioned, we will be using the JWK provisioner today. Provisioners are methods of authenticating against the certificate authority to get certificates for humans or machines. We offer different modes of authentication as well, such as SSO via OIDC, or by using Let's Encrypt's ACME protocol. Our developer advocate, Linda, who will have more coming soon on her blog about provisioners and what they can do for you and your infrastructure. For complete instructions, you can get to her documentation by going to smallstep.com, come to our certificate manager documentation, and go into the Kubernetes TLS guides. Today's guide I'm following is number 1 on how to use Step Issuer. In preparation for today's demo, I've already installed the software that is required and configured my certificate authority. Additionally, I've already applied my resource configurations to the cluster to have a certificate ready to show today. To get started, Cert Manager and Step Issuer into my cluster using their Helm charts. Here's a list of enter in the Cert Manager, namespace, and we have Step Issuer running in the Step Issuer namespace. I'm also going to run a command against my certificate authority to show my provisioners. These are all the provisioners I have set up on my authority. However, the one I'm looking for is called Step Issuer. Here's that particular provisioner. And I would like to take note really quickly of the key ID here, as well as the root certificate. The root certificate can be downloaded by running step ca root, and there it is. However, we will need it in base 64 encoding. We will need this value as well for our next steps. Locally in my directory here, I have 2 configuration files, certificate.yaml and issuerconfig.yaml. So I'll go ahead and cut out the issuerconfig.yaml. This config file is used to set up Step Issuer to be able to authenticate against your certificate authority, and specifically the provisioner that we set up previously. The template for this can be found on the guide that I referenced at the beginning of this demo. So here we specify the URL, the CA. I've copied in the CA bundle, which is the root and base 64 formatting. I say that we're using the Step Issuer provisioner. I also pass in a location for the password. In addition to the other things I've set up a password in the Step Issuer namespace called Step Issuer Provisioner Password. We can see here. This is where we store the password for the JWK provisioner. This is the secret that Step Issuer will use when authenticating against your certificate authority. Applying this, everything is good to go, and you can immediately start issuing certificates from your authority. So now let me show you the certificate resource. So this is a Cert Manager certificate resource. In here, I've defined some common settings, such as the common name and DNS names and IP addresses for on the certificate. I want the certificate to live for 24 hours, and I would like it to renew 8 hours before the certificate expires. So applying this resource, it will go ahead and create a certificate resource in the cluster, which I've already done. Inspecting that resource here, you can see that the certificate was in fact created and that it is in ready status. So once the certificate is created, it is stored in a secret in the step issuer namespace. And we specify the name of that secret as backend-smallstep-com-tls. So let me get the details for that here. And here we are. Inspecting that secret shows that inside we have a copy of the CA certificate, the TLS leaf certificate that we requested, and the corresponding TLS key to the TLS certificate we requested here. And now we can go ahead and use the certificate in any of our Ingress controllers. So I'll hand it off to Andrew, who will show us how.
All right, I'll go ahead and share my screen. So to use secret that has the cert key pair in it, 3 resources we're going to create is the Ingress resource. Now I've configured this resource, all traffic with hostname backend.smallstep.com to an internal Kubernetes service named backend on port 880. I've said that when there's any request for this hostname, to look up the cert key pair to terminate TLS in the secret name here, which matches the secret name and the certificate resource that Hunter just showed you. So this Ingress is going to forward all traffic to this internal Kubernetes service, listening on port 880 and sending all traffic out on pods that match this selector. And the pods are also listening on port 880. And here's a simple using for our application HTTP server, just to show. 2 other things that I've already configured ahead of time is I've configured the smallstep.com DNS name to resolve to in the cluster that was installed when I installed the Ingress Nginx controller. The service that was installed with the Ingress Nginx controller. And because we're on GKE, I hadn't provided this IP address. So I've already set up smallstep.com to resolve. One is I've gotten the root certificate and saved it locally. So now I can show you how we could connect to this securely. This is an echo server, so it'll just echo back whatever you send to it. So I'll just do something like this. And there you can see it's echoing back all the headers I have and also hi. And you can see the resources that we're using.
Awesome. Thank you, Andrew. So I don't see any questions in the chat. Please feel free to throw them up there. But we have received a few questions beforehand that we wanted to talk through here as well. So Andrew, I have a couple questions for you. What Ingress controller should I be using? Are there different ones for different services? And do any Ingress controllers do encryption automatically?
Controller you want to use really depends on what features you need. With the Ingress Nginx controller, the default feature that we just use is terminating TLS. You could also configure it to do upstream TLS. Like what features you need. Each controller kind of has its set of annotations that you could apply to configure it. If any that do any sort of automatic TLS without providing it a cert key pair.
Cool. Can I use something other than JetStack Cert Manager in this instance?
Is the easiest way to get certificates into secrets in Kubernetes. It's not the only way. You could use the step CLI commands, or you could use the step UI and get your certificate key pair, and then create it however you normally do, say with control or using Kubernetes client Go libraries. Cert Manager provides this nice CRD, which is the certificate resource, which helps you configure your certificate correctly with your expiration, your SANs, and everything you want.
Sounds good. What if I don't want to store a password? What other options do I have for authentication?
Are you talking about the password for the JWK provisioner?
Yes. Yeah. Say my policy does not allow me to use Kubernetes secrets.
Yeah, you could do actually since Kubernetes 1.21 is you could use the service account token, get a certificate directly from Step CA. Have an integration set up for that already, but that is something that you could write a couple scripts for. We also have another provisioner that uses Kubernetes account tokens, even the legacy one before Kubernetes 1.21. So you could take that token out of the pod and write a little script that will get your cert from hosted certificate manager or open source Step CA running in cluster.
Protocol. Can I use that at any point in here if that's a requirement?
Yes, Cert Manager's certificate resource works really well for Acme, especially with if you're doing web PKI. You're going to use step when you're doing private PKI for hosting don't resolve. Also functions as a nationer. So you could use with a certificate resource, and then instead of specifying let's encrypt for this CA, you just specify your authority on smallstep.com for the Acme provider. And in that case, you would not even have to use with JWK provisioner. You wouldn't have to install anything besides Cert Manager into your cluster. Registration authority for Smallstep that is able to resolve the domain names to issue the challenges to verify ownership in the cluster.
Makes sense. Can I use this method to use certificates internal to the cluster, like in a service mesh?
Mesh has different ways of getting their own certs. I think for Linkerd, you could provide it with an intermediate cert and a secret, and then it'll issue leaf certificates for all the different sidecars running in the myself. And there is some integration that would work. I'm not sure exactly how the other service meshes work.
In the Kubernetes documentation, there was another technology listed called AutoCert. When should I use AutoCert instead of Step Issuer if that is a requirement?
Yeah, so Step Issuer is great for getting your TLS cert key pair into secrets, which is perfect for Ingress controller and terminating TLS at the Ingress level, so you don't have to worry about that in your application. Really good if you want to inject certificates into pods in the file system automatically, and you don't ever want those to be stored in secrets. Some want their private key stored in a secret in etcd because it's easy to get Kubernetes and make it accidentally readable by the wrong parties. So AutoCert is a really good solution to pass all the secret. It runs as a mutating and it'll eject in a container to get the initial certificate into your pod and mount it in a shared volume. And then it also injects a sidecar to keep that certificate renewed. Manager takes care of the renewal for you and keeping the certificate updated.
Thank you, Andrew. I think that's all the questions we have here. It's for anybody in the chat to leave us any comments or questions. Okay. In that case, thank you everyone for joining us today. I hope you are able to take this information and use it to secure your Kubernetes workloads. If you have any questions or would like to see more tutorials and demos on the topic, we would love to hear from you. You can join our Discord server for all Smallstep open source projects. And you can contact our customer experience team via our intercom window on the website or ticketing system at support.smallstep.com. Oh, we actually just got a question. Right, Andrew, that was for you.
All right. What do you need to deploy for the auto cert? So cert, you don't need to deploy either cert manager or step issuer. Own Helm chart, and the Helm chart is going to install a mutating admission webhook so that every pod that gets created gets sent to the auto cert controller. And then based on the annotations for your pods, it may inject a init container and sidecar a single Helm chart that gets installed. Normally you install that to its own namespace. And then after it's just a matter of annotating the pods that you want certs for. All right, and then we have another question asking about the implementation of Linkerd step. I tried that out myself. Went too much on how that would work. Could you clarify what you mean by excluding MySQL and Redis? I'm not quite following that part. Actually, if you want to follow up with that, you could ask that question in Discord. It get you some more help that channel.
For what it's worth, I think I saw a ticket come in this week that's related to this topic. I don't know if you submitted it, but regardless, I'll circle back around with the support team, at least get back on that ticket, see where that one's falling. If sure, contact us either through the intercom window, smallstep.com, or you can go to support.smallstep.com to create a ticket at any point, and our support staff will get back to you. Providers to communicate instead of Smallstep. Oh, okay. Andrew, correct me if I'm wrong, but this sounds like a different use case, it being public PKI.
Yeah, I think would this be talking about client certs to connect to these backend services? Might be something that we'll need to dig into a little bit deeper to understand and provide some solid recommendations to you.
Sounds yes. If that wasn't your ticket, please absolutely put in the support.smallstep.com, and a member of my team will absolutely follow up with you soon. We're going to wrap it up here. Thank you again, everyone, for joining. We have a Discord server for open source of both our ticketing system at support.smallstep.com and the intercom window on our website. And for everybody for joining, we are here to help because when we are able to encrypt all the things quickly and easily, everyone benefits. Thank you for joining us and have a great rest of your day.
Thanks, folks.